Hello, my name is Madelyn Nice, and I will be talking about the hexagonal closed pack structure, or HCP for short. A hexagonal unit cell consists of two different sites that occur in an AB-AB sequence. This sequence repeats since only two positions are possible. This is what differentiates a hexagonal closed pack structure from a face-centered cubic structure, or FCC. A face-centered cubic structure has three possible positions for a closed packed layer, A, B, and C, rather than the repeating pattern shown by the three-dimensional illustration on the left. This is a recreation of the hexagonal closed pack crystal structure in Tinkercad. Both the top and bottom layers of the structure consist of 6 atoms, one at each of the lattice points of the hexagonal prism. They surround a single central atom. The middle layer has a plane that consists of 3 atoms within the prism. The distance between the atoms in the A sites to the distance between each of the atoms at the lattice point is 1.633. Similar to the FCC, the coordination number is 12, and the atomic packing factor is 0.74 respectively. Now that you know the basics of HCP, you can now determine the directional indices. This is an illustration of a 4-axis Miller-Bravais coordinate axis system. The red lines indicate the axes for which to compare the vectors A1, A2, and A3 are on the same plane and are 120 degrees from each other. These represent the first 3 vector coordinates in the bracket. The z-axis is perpendicular to this plane. This is the 4th vector coordinate. Now take the yellow line as the vector you want to find the indices for. The vector is 90 degrees from both the A1 and A2 axes. When you project the point of interest, which is when the vector comes into contact with the prism, to each axis, you get A1 divided by 2 and A2 divided by 2. Half of each respective axis is written initially. The vector is also opposite the direction of the A3 axis, so that coordinate becomes -1. There is no direction attributed to the z-axis. The directional indices referenced to the 4-axis coordinate scheme is then changed to whole numbers and enclosed in a square bracket without spaces. Now let's say you want to convert to a from a 3-axis coordinate system to a 4-axis scheme. Let's use the example from the previous slide. We can take the coordinates obtained for the A1, A2, and Z axes as U', V', and W' respectively to describe the 3-axis coordinate system. You take these coordinates and plug them into the following equations to obtain the same directional indices as before. 1/3 to U' minus V' becomes 1/3. 1/3 to V' minus U' becomes 1/3. Negative U minus V becomes -2/3. W is simply equal to W'. Always make sure the coordinates are given in whole numbers and no spaces between them in the square bracket. Now this can go for any vector that you choose. So let's say you want to go from 3 to 4 axis and you have a vector. You can define as a 4-axis or a 3-axis, but if you wanted to convert a 3-axis scheme to 4-axis, this is how you would do it. And these are my references. Thank you so much for listening to my presentation.